All right, question says, market research performed by a buggy company suggests that the demand equation for its buggies is given by Q equals negative 0.7 P plus 180, where Q is the number of buggies that they could sell in a month if they set the price to P. All right, so first of all, like, how do they even come up with a formula like that? All you have to do is take several different time periods. Like, let's say, month 1, month 2, and month 3. And then set your price of your item to different values so you can experiment, right? Let's say they bring these buggies to market, right? And they set the price to $10 per buggy. And then in month 2, they raise it to $20 per buggy. And then in month 3, they raise it to $30 per buggy. Okay, so these are the prices. Then what they can measure is the demand for like how many people are willing to buy these buggies at these different prices. So let's say in the one case, people buy 173 of the buggies. Okay, but then when they set the price to $20, people don't buy as many. They only buy like 166 buggies. And then let's say at $30, 159 buggies are sold. However, simply raising the price doesn't necessarily mean you're going to make more profit. We have to take into account not just the price that they're selling them at, but how people are willing to pay that price impacts the overall revenue that this company gets. So it might be intuitive to think like, okay, let's just raise our prices and then we'll just make more money. That's not necessarily the case, because less people are going to be willing to pay those values. Okay, so what they could do is they could do this market research, right, and get several different points which could be plotted on a graph. You want to pay close attention to the variables in your problem and see what is the input and what's the output. It would make sense in this type of situation, if you're drawing a demand curve, to let your input variable be the price. So if we put price on the horizontal, then how people respond in their purchases would be like the demand. And we call that the letter Q. And it's just going to be a number of items sold. However, just be aware that in these problems in this section, you can also see P as a function of Q. A lot of problems will interchange the axes. So in this case, I'm going to make Q my vertical variable. That actually makes sense for the situation that I'm describing, because the company is setting the price. So that's something they control. But what responds to the prices they set, of course, is the purchases, buying the buggies. Okay, now, is this a true experiment that they're doing? I would say not. This is not a controlled experiment. There could be other market factors that impact how people are purchasing these items. There could be like a baby boom or something in month 1 and not in month 3 that could impact how many buggies they're buying. There could be a worse economy in month 3 versus month 1, which impacts their purchases. So just keep in mind that if we were to do a fishbone diagram where Q appropriately represents the buggies purchased, and you're trying to explain why they're purchasing the buggies, the price is one possible explanation for why those numbers of buggies are being purchased. But we have to acknowledge that in reality, it's not the only explanation for why they're buying the buggies at those prices. Like I said, the economy could have something to do with it. The population needs could have changed from month 1 to month 2. Maybe they just need more buggies because it's a baby boom. Or it could be changes in other suppliers in the area. Like if one place goes out of business, then that could affect how many people shop at your shop. All kinds of things. There could be other explanation too. This is not a controlled scientific experiment. However, it could have value. So what they can do is plot these points. There's going to be 3 points here that we can plot. Let's see if we can do it in Desmos. We want price as our horizontal, demand as our vertical. So one possible pair would be 10 with 173. And we can have 20 with 166. And 30 with 159. Now I'll try to find my data. There it is. Okay, now what we can do is we can do regression on the data that we collected. In this program, though, we first have to enter it into a table before we do the regression. So I just want a table showing those same values. The X's will be 10, 20, and 30. Those are the prices. The demands are 173, 166, and 159. Now if I label these with the letters that the question had gave, we'll make the horizontal P and the vertical could be Q. And we want the formula Q tilde M P plus B. However, we have to put ones on our P's and Q's. Now I just went with the simplest case. I went with a linear model. There could be other models, though, for this situation. You could do an inverse curve, like Q1 tilde K over P1, if you thought that was appropriate. In some cases, we would do an inverse curve, but I'm going to do linear just for the simplest case. You get a slope and an intercept. There's our regression line. Our intercept here is 180. That's a demand, that's a number of units. Well, that corresponds to a price of 0. That would mean if they said, people just come and take the buggies for free if you want them. The model predicts that 180 buggies would be demanded by the public if the price was 0. Now, is that extrapolation or interpolation? It's certainly extrapolation. Okay, it's extrapolation because we didn't take data at a price of 0. And so it's not expected to be perfectly reliable. There's another important point that would be here. And what would that correspond to? That would correspond to a demand of 0 because we're on the horizontal axis. And so this is where there's a certain price where the price is just too high and people won't buy them. The answer to the first question, what would be the demand if the company was to just give the buggies away? They would demand 180 units. What would be the demand if the company was to set the prices at $60 per buggy? We'd want to be finding Q of 60. So use your formula. And let's see what we get for that. 138, I get. Okay. What would be the demand if the company was to raise the price all the way up to $140 per buggy? And yeah, like I was alluding to, we'll show that just raising your prices in a free market does not mean you're going to make more money. Because less people are going to agree to purchase the item that you're raising the price on. And you have to compete with your competitors. And so if they can get the buggies cheaper somewhere else, then oftentimes they'll find a way to do that. It's supposed to be in the free market that you don't have a monopoly on these things. So raising your prices sometimes isn't the right approach, as we'll see. Only 82 buggies will be sold in that case. So it says here, according to the mathematical model for demand, at what price would the demand be 0? So that would be this case right here that I'm talking about. We would want to set Q equal to 0 to find this maximum price that's too high. We have our formula. Okay, so let's plug in a 0 for Q. I get 257.14. All right, so how do we determine the right price to set for the company? What we can do is we can create a revenue function. A revenue function tells you how much money is going to be coming into your business through sales, for example. So if you sell these buggies at a certain price, we can actually calculate how much money you're going to be making from those sales. There's a formula for revenue. It is that the revenue will always be given by Q times P. Q stands for the number of items being sold. P stands for the price that you're selling them at. Now in this problem, we can substitute in for one of the letters. You could do it either way. You could substitute in for Q if you want. So that would be making revenue as a function of price. Or you could, if you wanted, create a function R in terms of Q. Because we're talking about the company arbitrarily setting the price right now, I'm gonna focus on this one. I want to find out what the revenue for the company is going to be dependent on the price that they set for these buggies. So with that in mind, I want to actually substitute out Q, and what I would substitute in for it is the formula that we have now for Q. Put some parentheses where Q used to be. Keep that P still in there though, and now plug in the regression equation that you found earlier. Now I'll simplify it. And this tells us how much revenue the company is going to get from their sales. And so we're going to see that there's an ideal price for them to set in order to make the most amount of revenue from the consumers. And we'll see that just setting a higher price doesn't lead necessarily to them making more revenue. They'll actually make less revenue if they set the price too high. So the free market is supposed to correct itself when prices are too high. And that's what I mean when I say that a company just raising their prices doesn't mean that they're going to get more money, because maybe instead of visiting their business, consumers can go to other businesses that have lower prices and give them the money instead. So let's go ahead and plot this function though. I'll plot it on the same axes as the demand equation here. Okay, so here's the graph I get. It's a very tall parabola here. I'm going to draw it next to this graph here because they're kind of at very different scales right now on the Desmos. There are intercepts for this parabola occurring at the origin and also below the intercept of the demand equation. And the rest of the parabola just looks like this. Okay, that is the revenue function, or RFP. Our horizontal axis is still price. Our vertical axis is a revenue in dollars. And what I am going to propose here is that there's certain prices where we won't make any money as a company. One of those prices is if you set the price of the items to 0. If you just give them away, then there will be no revenue flowing to your company, which would be bad for the company. Also, if we set the price too high, according to the model, if we set it to $257, then that is so high that nobody will buy the item. And again, the revenue is 0. But there is some ideal price for this company to set based on their market research that should yield the optimum amount of money. And that's where there's a peak at the revenue function. And that's what we need to find. What is that ideal price for maximum revenue? Let's see if we can find it. If you're doing it with the algebra approach, you have to look at your quadratic function, identify the A, the B, and the C in your quadratic. So your A is negative 0.7, your B is 180, your C is 0, there is no C. And so for a parabola, we can always find the location of the vertex with a formula, negative B over 2A. That only works for parabolas though. So let's plug in our B and our A. 180 goes there, negative 0.7 goes there. So the ideal price is there for 128.57. Halfway between 0 and the maximum price in this case.